So to kick things off, I'm Jason Butz. I'm a principal architect at Encora, and I'm here to talk to you about chaos engineering, FIS, and Lambda functions. So to start off, who's heard about chaos engineering? Okay. And in what kind of context have you heard about it? Anyone, go ahead and shout it out.
Networks, testing for how durable.
Okay. All right. That is an answer I've not heard before. Normally I hear Chaos Monkey. Chaos Monkey is something I know a lot of engineers have heard about. It was something that Chaos came up with where it would randomly kill EC2 instances. But absolutely, like networks is another big piece of making sure things are working correctly and things fail like you expect. And that's really one of the hearts of chaos engineering, is making sure that you understand how something's going to fail. It's really easy to test the happy path for your application or for your system, but when it comes to those failure cases, making sure that one, it fails like you think it will, and that you can recover from that gets a little tricky. Especially if you don't have direct access to the network or routers, things like we just heard about. So what is FIS? FIS, or Fault Injection Service, is a part of the Resiliency Hub, and it's a service that can help you to discover your application or your workload's weaknesses at scale through experiments. And that's kind of the important part, the experiments. That's the difference between, I think it was Mythbuster, Adam Savage on Mythbusters said, the difference between messing around and science is writing it down. Well, experiments make it science, right? So as of the end of last year, and I don't think this count has changed, FIS supports 18 different types of resources. And it's things like, your Aurora or RDS databases, DynamoDB, EBS, various different resources within EC2. But the piece that really got my attention and got me to start digging into it was Lambda functions. For a long time, that wasn't one of the capabilities, and I do a lot of serverless work, and so I hadn't paid too much attention to FIS. So I mentioned experiments. FIS, or the experiment, is really the heart of the FIS service. And it's really the experiment template that's important. And those templates have really two major pieces. You have your targets, that is the resources, whether it's a single resource, a group of resource, that you're wanting to impact with this experiment. And then it's the actions. What are you wanting to do to that resource? And you can have multiple targets, multiple actions, and one of the great things is you can actually start chaining things together. So if you want to test something simple, like a chaos monkey will say, maybe you want to just randomly terminate 1% of your production instances, you can do that. But if you want to do something more complex, where you want to start by disrupting connectivity in a specific subnet, and then you want to start terminating instances in that subnet and see how things respond, whether you can actually recover correctly, you can absolutely build an experiment that's going to let you do that. One other important piece to note and remember with these experiment templates in FIS is the stop condition. Stop conditions are optional, but they're there so that, if you're testing in a production environment or an environment that you're not allowed to just take down, it gives you a way to stop that experiment and not have that continue. Or it's a way that if you're testing for a certain condition, you can detect that that's occurred and terminate the experiment. You don't have to sit there and let this experiment continue running when you don't need it to. And ultimately, the stop conditions are just a CloudWatch alarm. So when it comes to FIS and Lambda, there are 3 different types of actions that you can take on a Lambda function. The first is an invocation delay, and that's kind of like a cold start a little bit. It's not exactly the same, but it's sort of similar. It's a way to delay the actual execution of your Lambda function handler. There is also the invocation error, And that's a way to simulate an error occurring when you're actually trying to start up that Lambda, kind of like maybe there's something going on with the runtime or with the Lambda service. That's a way you could potentially simulate those kinds of errors. And with those invocation errors, you can also choose to allow your handler function to still run in the background, even though within the course of your experiment, you are simulating that error. And for me, my opinion, I think that's something like if you have you want to test if something's actually idempotent, or if you know it's idempotent and you don't want to interrupt maybe a production application, this is one way you can still let that logic continue even while you're running that experiment. And then lastly, there's the HTTP integration response. And this is intended for use when you're working with an application load balancer, API gateway, and some of those other resources. And it allows you to set the content type and the response code that's going to come back from your Lambda function. So for example, maybe you want to just return a 502 for everything. This lets you do that. You cannot set the HTTP body. That's something that I think I'm missing, and I've got my fingers crossed that AWS is going to add that soon. I think that would be incredibly useful in developing more complex experiments, but it's currently missing. And you can also, like with the integration error, you can choose to let the handler function still run in the background, even though you are returning this error. To set up and use FIS with your Lambda functions, you do have to have space to be able to add an additional Lambda layer. That Lambda layer is a critical piece of using FIS with Lambda. That layer is responsible for actually going out, pulling the configuration for your experiment, and then it's what's actually, adding that invocation delay, what is causing that simulated error to occur. FIS is really just creating the configuration. It's that layer that's doing all of the real magic. So to kind of give you a little bit of an example case, let's say that we have this serverless application where we have messages coming in through our API, they're getting put on a queue and processed by a Lambda function. And the message fails to process a few times, it'll end up on our dead letter queue. And then once something hits the dead letter queue, let's say we have an event bridge pipe that then ties into some other additional logic down the line that we can use to help more automatically resolve those errors. So let's say for the sake of this scenario that event bridge pipe and all that downstream logic is something that's new. We want to test it. We think it works. We can just send some messages straight into the dead letter queue and that works fine, but we still don't have everything working all the way end to end. But how are you going to purposefully have your Lambda function fail to process something? Again, it's that testing those failure states, that non-happy path. Well, this is where you can start building an FIS experiment. So let's say, what are we wanting to do? We're wanting to get these messages that instead of being successfully processed by this Lambda function, we want them to be kicked back onto the queue enough times that they're going to end up on the dead letter queue. And so what we can do is we can add an invocation delay in our experiment. And if we make that invocation delay in excess of the Lambda function timeout, we can guarantee that it's always going to be failing to process that message. And then after that visibility timeout, that message will reappear in the SQS queue, get processed again, or attempt to be processed again, and then we'll get return. It'll fail to process, and we'll be able to get that maximum number of receives without it actually being processed. As far as a target, this is a pretty easy case. We know what Lambda function we need to target. We're just going to impact it 100% of the time. That way we can get our tests done and we can stop, potentially breaking the development environment. And one thing that is important that we need to think about here is how long do we need this experiment to run? We want to, so in this example, we've got, 3 maximum receives, and we have a visibility timeout of 60 seconds. So if you're doing something like this, you know, okay, it needs to be attempt to be received by the Lambda function 3 times. 3 times 60 seconds, 180 seconds or 3 minutes is going to be the minimum amount of time we need in order to ensure that everything is, we're able to get a message to fail correctly to that dead letter queue and then flow through the rest of our application. But it's better safe than sorry, and so I say add a couple minutes just because there can be some wiggle room in there, and make it 5 minutes. Now, normally at this point, I would show you a demo, but the demo, because of the setup, that 5 minutes and everything else, takes 10 to 15 minutes. So what I did do is I'll have a QR code at the end, is I did that demo separately, I recorded it, and I've got it posted online. It is my first attempt at doing the video editing in order to put together a video like that, so please excuse the horrible video editing. I'm not going to be changing careers, but that is really the heart of what my talk is. And so at this point, what questions do you all have?